So in this video, I'm going to show you how to solve rational equations. A rational equation is just an equation that has lots of fractions. So if we take a look at this equation here, we've got 1/2 x plus 2/5 equals 9/10. Our goal is to get rid of the fractions. I'm going to get rid of the fractions by finding the LCD as if we were adding these three fractions together. But we're not adding them together because it's an equation. But we're going to do it as if we were adding. So we want to factor our denominators, write them in their prime factorization. Or 2 is a prime number, so it's already factored. 5 is a prime number. But 10 can be broken down to 2 times 5. So remember, when we found the LCD, we first see what they have in common, all three of them. They don't have anything in common with all three of them do. So now we see what do pairs of them have in common. Well, we have a pair of 2's, and we have a pair of 5's. So the LCD, if I was adding these fractions together, it would be 2 times 5, which is 10. So here's what we're going to do with them. We're not going to rewrite each fraction so they all have the same denominator. What we're going to do is we want to multiply the whole equation by the LCD. Since this equation has 3 terms, I'm going to be multiplying by 10 3 times. So what I like to do is I just like to write out 10 3 times over here to the left. So I'm going to take 10 and multiply it by 1/2. So what we're doing is we're taking 10 over 1 times 1/2 x. Well, I don't know if you guys recall, when you multiply fractions, you can cross cancel or cancel up and down. This 2 can cancel with that 10. So that becomes just 5. So here's what we're going to do. The way we have it set up is we have it set up so our denominators will cancel with these 10s. This 2 will cancel with the 10, so it'll become the 5. So now I'm going to take 5 times 1. And that'll be 5x. And then I'm going to do it again. So now I'm going to take 10 times the fraction 2/5. Well, my denominator of 5 goes into 10 twice. So this will be 2 times 2, which is 4. And then last, we've got our equal sign. I'm going to do it one more time. I'm going to take 10 times 9 over 10. The 10s will cancel each other out. And that just becomes 1 times 9, which is 9. Doing this makes it easier to solve. Getting rid of the fraction makes it easier to solve. Now we just have a 2-step equation here. So we could subtract 4 from both sides. We got 5x is equal to 5, and then that's x is equal to 1. And that's my solution. Okay? That was a simple one. We have done ones like this before. It was like beginning of the year we've done ones like this, like the beginning of the school year. But now, what we're going to do is we want to put some variables in the denominator besides just numbers. But you guys know enough to do this. So again, we're going to do it just like we did the first one. Let's write our denominators in the prime factorization. Well, x is just x. And this x is just x. And then 6 can be broken down to 2 times 3. So first you're going to look and see what if there's a common factor that all 3 has. None of them, all 3 of them don't have anything in common. So then after you see what all 3 have in common, you do pairs. Well, we have a pair of x's in common. So the LCD would be your pairs, which is x, and then whatever's left over. So what's left over? A 2 and a 3. So my LCD is 6x. So I'm going to multiply this whole equation by 6x. And I got to do it 3 times because I have 3 terms. So I'm going to take 6x times 1 over x. For the x in the bottom, we'll cancel the x up here. So this just becomes 6 times 1, which is 6. And I'm going to do it again. 6x times 2 over x. The x's will cancel each other out. So we get 6 times 2, which is 12. And then last, you're going to take the 6x times 1, 6. Or the 6 will cancel with the 6. So we have x times 1, which is just x. So here's our equation now. 6 plus 12 equals x. 6 plus 12 is 18. So we got 18 is equal to x. Now the last one, I didn't check my answer because I didn't need to. But anytime you have x in your denominator, you got to check your answer. You got to make sure the answer that you get doesn't make your denominators equal to 0. So our original denominator was x. If I plug 18 back in for x, that's not 0, so that's fine. If I plug 18 here, that's not 0. As long as the denominator is not 0, we're good. So our answer is x equals 18. All right, I got a couple more examples I'm going to go through here with you guys. Just look at this one. It says solve the given rational equation. Well, we only have one fraction equal to a number. You can think of 2 as a fraction. Think of it as 2 over 1. Okay? So if we if we factor our denominators, well, we get x plus 4. Well, x plus 4 is prime. It can't be factored. And then 1 is prime. So my denominators don't have anything in common. So if they don't have anything in common, your LCD is whatever's left over. So it'll be 1 times x plus 4. And 1 times x plus 4 is x plus 4. So what I need to do is I need to multiply this whole equation by x plus 4. But unlike the other two, we have 3 terms. On this one, we only have 2 terms. So we're only going to multiply by x plus 4 twice. So when I take my first x plus 4 times this fraction, 1 over x plus 4, the x plus 4's cancel out, I just get 1. And then when I take x plus 4 times the 2, the denominator on the 2 is a 1, right? 1, it doesn't divide into x plus 4, so nothing cancels out the x plus 4. So you're going to take the x plus 4 times the 2. So you're going to make sure you take the 2 times the x, which is 2x, and then 2 times 4, which is 8. Okay? Another way I could have done this problem, which is a little easier than doing it that way, is if you look here, if we go back and look at the original problem, we have 1 over x plus 4 is equal to 2 over 1. What we have here is something special. We got a fraction equal to a fraction. Okay? This is called a proportion. The easiest way to solve proportions, you don't have to find the LCD. Anytime you have a fraction equal to a fraction, okay? So if you have one fraction on the left side equal to one fraction on the right side, you can do this. You can just cross multiply. 1 times 1 is 1, and then 2 times the quantity x plus 4 will be 2x plus 8. So all we need to do now is just solve this. So solve the equation. So to solve this equation, we would subtract 8 from both sides. We get negative 7 is equal to 2x. Divide by 2. So x is equal to negative 7 halves. And then double check it. Plug negative 7 halves in for x in your denominator. Make sure it doesn't make the denominator 0. It doesn't, so it works. So our solution is x equals negative 7 halves. All right, one more example here. This one looks difficult, but it's not that bad. So again, our first step is to factor our denominators. Well, x minus 5 is prime. X minus 3 is prime. But x squared minus 8x plus 15 can be factored to the quantity x minus 5 times the quantity x minus 3. All right, do any of my three denominators, look at them. Do they, all three of them have something in common besides one? No. So now let's pair them up. We have a pair of x minus 5. And we got a pair of x minus 3. So my LCD would be the quantity x minus 3 times the quantity x minus 5. So this is what I'm going to multiply the whole equation by. Okay? So I'm just going to erase this. So remember, this was already factored, this was already factored, and then this factored to x minus 3, x minus 5. So I need to multiply my whole equation by this, and I got to do it 3 times. So I'm multiplying it by this 3 times because I have 3 terms in this equation. So when I take my first one times my first fraction, the x minus 5 on the denominator would cancel with this x minus 5. So we're just going to have 1 times x minus 3. And then I got plus, because of my plus sign here. I'm going to take x minus 3 times x minus 3 times x minus 5 times this fraction. Well, the x minus 3's cancel out. So we're going to have x times x minus 5. And then when I take this times my last fraction, well, in our denominator we have x minus 3, that cancels with that x minus 3. This x minus 5 cancels with that x minus 5. So this becomes a 1, and then 1 times 2 will be 2. So if we clean this up a little bit, 1 times x is 1x. 1 times negative 3 is negative 3. X times x is x squared. X times negative 5 is negative 5x. That's equal to 2. Combining our like terms on the left side, we've got x squared. We can add these 2 terms together to get negative 4x minus 3 is equal to 2. So what we have here is not a linear equation. This is a quadratic equation. So to solve a quadratic equation, you get all your terms on one side, and the other side equal to 0. Move all the terms so that your quadratic term is positive. So we're going to move the 2 to the other side. So we're going to subtract 2 on both sides. We'll get x squared minus 4x minus 5 is equal to 0. And then we can solve this by factoring. So this factors to x minus 5 times quantity x plus 1 equals 0. So we can find our solutions here. We're going to set each of the factors equal to 0. So we got x minus 5 equals 0. Add 5 to both sides. One of our possible solutions is x equals 5. Our second possible solution, we're going to take x plus 1, set that equals 0, minus 1 on both sides. We'll get x equals negative 1. Remember, we had x in the denominator in our original problem. So, right here, remember this factors to x minus 3, x minus 5. If I take 5 and I plug it in for x there, I get 5 minus 5, which is 0. It makes that denominator 0, which we can't have. You can't divide by 0. So we can't use x equals 5. X equals 5 is called an extraneous solution. So it looks like it's going to work. And it should work because we did all the math. But when you go back and check it, it makes something that's not possible. You can't divide by 0. Does negative 1 work? Well, if you plug negative 1 there, that's fine. Plug negative 1 here, it's fine. Plug negative 1 here and here. Doesn't make any of my denominators 0, so I can use it. So this one only has one solution. One solution is x equals negative 1.